Hello friends, welcome to my channel Physics with Rakshit. We know that we are seeing the book Look Quantum Gravity for Everyone, authored by Rodolfo Gambini and George Pulling. In two previous videos, we show some fundamentals of quantum gravity and fundamentals of general theory of relativity. In the present video, we will see some fundamentals of quantum theory. And in the fourth lecture, we will enter in the fundamental framework of loop quantum gravity according to book, which is fundamental for all like physicists, amateurs, and those who want to understand what is loop quantum gravity. So we know that earlier Greek philosopher believed that matter is made up of atoms, and some Indian philosophers like Kana, who gave Vaisheshika Darshana, Vaisheshika philosophy, who also believed that matter is made up of paramanu, which we call atoms. And thereafter, Dalton came up with some chemical reactions that includes atoms and molecules. To understand some electrical and other physical phenomena, afterwards, some physicists came up with various atomic models like plum pudding model given by Thomson, other model given by Rutherford. These both models were unsuccessful to explain stability of atom and nucleus. Thereafter, various physicists described fundamentals of quantum physics. In the beginning of 20th century, Max Planck gave quantum physics to explain black body radiation curve, and he quantized energy of black body, that is E is equal to hf. Afterwards, Niels Bohr quantized angular momentum of particles which are rotating around nucleus, and various physicists gave atomic model which could explain stability of atoms including nucleus. We know that in nucleus there are neutrons and protons which are also made up of quarks. Around nucleus, electrons are orbiting in orbits, and subclass of orbits are suborbitals, which are described in atomic physics that I will not discuss here. There are many fundamental laws of atomic physics like Aufbau, Pauli, Hund, and many others that describes atomic physics in quantum manner. And there are some quantum numbers that describes atom successfully by considering quantum traits like principal quantum number, angular momentum, magnetic, etc. that we will not discuss here because of time limitations. Thereafter, physicists came up with various interpretation of quantum mechanics, various ways to understand quantum mechanics. First of all, Schrodinger, Max Born, and many other physicists described wave mechanics, which is one way to understand quantum physics. Thereafter, Heisenberg and other physicists came up to understand wave mechanics with the mathematics of matrix. And Paul Dirac came up with mathematics of operators in operator mechanics. These three are different windows to see the same problem, that is quantum physics. Here, why quantum mechanics is very difficult to understand. In classical mechanics is completely deterministic, continuous, and there is no bizarre traits like quantum mechanics has. Quantum mechanics is probabilistic by nature. It considers superposition. In quantum mechanics, physicists study microscopic particles, and this is the reason why it is very difficult to understand their mechanics. It considers duality. It means sometimes reality behaves as wave, sometimes reality behaves as particle. And that is why de Broglie came up with this theorem regarding duality, which is known as matter waves. We know that quantum mechanics is also uncertain. Heisenberg gave his universal uncertainty principle, according to which position and momentum or energy and time cannot be measured simultaneously. Quantum mechanics also exhibits granularity. It is probabilistic by nature, and that is why physicists like Einstein and Schrodinger in the beginning hate quantum mechanics because of this trait. And there was a one disputable debate between Einstein and Niels Bohr regarding the interpretation of quantum mechanics that we know. Another thing is general theory of relativity that studies macroscopic world is also continuous, deterministic, and which doesn't have probability. So it is very difficult to quantize gravity, which is explained by general theory of relativity in quantum mechanics. Thereafter, in 1905, Einstein came up with special theory of relativity, and physicists unify special theory of relativity with quantum physics, and quantum field theory was born. There are three quantum field theories. In the previous video, we saw some basics. In quantum electrodynamics, we study electromagnetic interactions, which is mediated by photon. In quantum chromodynamics, we study strong nuclear force, which is mediated by gluons. In quantum flavor dynamics, we study weak nuclear force, which is mediated by plus or minus W or Z0 boson. By unifying these three quantum field theory, we can have grand unified theory, which cannot unify gravity in this framework because of certain difficulties. Like these three theories are renormalizable, as we can get rid of infinities and anomalies which are occurred in the equations. But gravity is non-renormalizable theory in quantum field theory framework, and this is the reason I am describing loop quantum gravity. Loop quantum gravity describes quantization of gravity with novel quantization technique that I will explain soon. In quantum mechanics, there is one bizarre experiment designed by Thomas Young, according to which when electrons are emitted from source, it will pass from one slit. Thereafter, becoming coherent, they will pass from two slits. Here, problem arises. We cannot say whether electrons will pass from this slit or this slit if we consider electrons as particle. But if we consider electrons as wave, we can have pattern, interference pattern on screen because of superposition of waves here. And we can have like this pattern. Here, problem is if I put detector in the path of these electrons, electrons will spontaneously behave as particle and its wave function will be collapsed according to quantum mechanics, particularly Copenhagen interpretation. And that is why, including physicists, quantum mechanics is very difficult to understand, as we cannot say when and where matter or any particles will behave either wave or particle. So quantum mechanics is non-deterministic, and there are many bizarre traits like I explained, probability, granularity, etc. To understand these problems more clearly with some up to some extent determination, Richard Feynman came with his approach, which is known as sum over history. He considered aggregate results of all waves by integration, and he gave this approach sum over history. By this method, we can get rid of infinities up to some extent, and we can study renormalization of these three theories in quantum field theory. We know that in the second video, I explained that gravity is not force, rather it is deformation of space-time. This trait is the biggest hurdle in quantizing gravity in quantum field theory. Earlier, I explained that there is one class of quantum field theory, that is Yang-Mills theory, which studies various quantum field theory like quantum electrodynamics, quantum chromodynamics, quantum fluorodynamics, grand unified theory, in which there are several electric and magnetic fields which are interacting with each other. And to understand loop quantum gravity, you have to understand Yang-Mills theory first. Then and then you can enter in the realm of loop quantum gravity. To understand quantization of gravity, nowadays there are two promising candidates. First one is string theory, which was originated from quantum field theory, and that is why it considers background dependent. You have to consider prior space-time to understand trajectory of various particles. In string theory, like if you break it any object into small particles, and if you see these small particles, we will have atoms, and in a nucleus we have quarks, which are made up of vibrating filament of energy. In string theory, it is known as one-dimensional strings. Actually, there are many varieties of strings like 0 dimension to 9 dimension. In string theory, it is known as membranes or D-branes. Let us see some interesting facts of string theory. String theory is background dependent as it doesn't consider one of the important symmetry of physics, that is active diffeomorphism invariance. It only considers passive diffeomorphism invariance. Another bizarre traits are, to understand string theory, we require some unusual and difficult mathematical concepts like supersymmetry, which is not yet observed. We require 11 dimensions to understand string theory, which we cannot imagine or perceive by naked eye. There are several bunch of particles to understand reality in string theory, and it can explain microscopic as well as macroscopic aspect of reality or nature, but by these cost. But in loop quantum gravity, it is conservative approach. It is background independent. As in general theory of relativity, we describe gravity using geometry. Loop quantum gravity is another name is quantum geometry. Here, what we are doing, we are quantizing geometry of space-time. And Carlo Rovelli, who is one of the father of loop quantum gravity, once told that in loop quantum gravity, loops are one-dimensional objects that form in space, while in string theory, strings are one-dimensional objects that moving in space. So this is the main and key difference between string theory and loop quantum gravity. Similar to string theory, which is originated from quantum field theory, here loop quantum gravity is originated from general theory of relativity. So in loop quantum gravity, we require novel quantization techniques as it doesn't consider classic way of quantization in quantum field theory. It considers usual 4 dimension, and that is why we can perceive and imagine. Here we don't require some imaginary concept like supersymmetry and extra dimensions. So it is conservative approach, and that is why I worked in low quantum gravity. Here space-time will emerge naturally as it studies gravity by studying geometry. Here one problem is that we cannot understand order of time. Like there is one problem, frozen time, but there is one solution also in loop quantum gravity by considering dynamical framework of loop quantum gravity, which is spin form, which is evolution of spin network. We can have solution of this problem. Similar to quantization of matter, if we quantize matter, we can have atom. If we quantize electromagnetic radiation, we can have photon. If we quantize space, we can have atom of space. that I have shown here. I will describe what is atom of space, what is spin network, what is spin form in the fourth video of this series. Up to some extent, according to book, as loop quantum gravity is very complex theory, as I explained earlier in the first and second video. So in the present video, we see history of atomic and quantum physics, bizarreness of quantum mechanics, why gravity is not quantized in quantum field theory, discrepancies between string theory and loop quantum gravity, and why we will study loop quantum gravity in this book, that is loop quantum gravity for everyone. Thanks for listening. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding this lecture, you can ask in the comment section. We will start loop quantum gravity from next video.